we're just going to get an introduction to finding intersection points, and I'll show you how to find them on Desmos as well, but we'll do more with these later in the course too. So the point of intersection from two linear functions can be found algebraically by setting the two functions equal to each other. Because the idea of the intersection point is basically, where do they have the same coordinate? So if we're graphing two lines, which is what we're focusing on here, the idea is that there's this shared coordinate, xy, that is the solution for both equations. So where it should be occurring is where these two equations are equal to each other. Same x value, same y value. So our final answer for these should be an xy coordinate. So find the intersection of the lines f of x equals 3x minus 4 and g of x equals 5 minus x. So what I'm going to do is take that 3x minus 4 and set that equal to the 5 minus x, and then it becomes an equation for solving for x. So I'm going to add x to both sides. So I have 4x minus 4 equals 5. Add 4 to both sides. So 4x equals 9. Divide both sides by 4. So x is equal to 9/4. We're not done yet because we need the y coordinate as well. So to get the y coordinate, the x value should be the same for both of these functions. So what I can do is just take that x value and plug it in to either function. It doesn't matter which one. I'm going to go ahead and use this 5 minus x just because it's a little simpler. So we should be getting this y equals 5 minus x, and we're having x equal 9/4. Need to do a little fraction work here. Let's see, 5 is the same thing as 20/4 minus 9/4. So 20 minus 9 will be 11 over 4. So our answer is the coordinate 9/4, 11/4. If we wanted to double check that, we could plug it into both equations. So let's do that with our scientific calculator real quick. So going to 3x minus 4 and 5 minus x. Oops, where did my screen go? Okay. So 3x minus 4, so 3 times 9/4 minus 4. Oops, my formatting got off there. Minus 4. So it's giving me a 2.75. If I just use that convert to fraction button, there's that 11/4. Fantastic. And then we already found it, but 5 minus 9/4, that same 2.75 or 11/4. So these balance out. So this is our solution. Now let's talk about looking at the graph of this. So we have our function 3x minus 4 and 5 minus x. So f of x, we have a y-intercept at -4 and then a slope of +3. So we're going to go up 3, right 1. So up 3, right 1. And then I'm just going to graph a few extra coordinates as well following that trend. Okay, so connecting those together, there's our graph of f of x. Let's do the same thing with 5 minus x. So with this, it's a +5 intercept and then a -1 slope. So we're going to go down 1, right 1, down 1, right 1, so on and so forth. Okay, so if I connect those, that'll be a graph of g of x. Okay, so our answer is coming in right here with x and y. Now, if I had to solve this just graphically from the beginning, I'd be like, okay, there is a solution, but visually it's really hard to tell. So graphing can be nice when it lands on a nice even number. With this particular graph, and we've found the answers already, so we know it's kind of messy fractions up there. So with that on the graph grid, we get an idea. Like I can tell that x is 2 and a little bit, and y is 2 and maybe like just a little less than 3, which we actually saw from the calculator. That's a 2.75. But in terms of an exact solution, it's hard to tell from the graph. So we do want to be able to do this algebraically so that we can get these exact values out. But another tool we can use is the graphing calculator in Desmos if we graph these two functions. So if I do the 3x minus 4 and then 5 minus x, when we graph these different lines, Desmos likes to show off the kind of important coordinates or points of interest. It'll typically include the intercepts, but when you graph two lines, the intersection point will be highlighted. So there's this 2.25, 2.75 coordinate where they're intersecting with each other, which lines up with the decimal form of our fraction solution that we found before.